Howdy. We are at Life Science, and I'm trying to make a video about this. It's about 2 days or something, gathering some other information about things, but it seems to be very difficult. So let's just go through the article. Surprise discovery of world's second deepest blue hole could provide window into Earth's history. The second deepest blue hole in the world has been discovered off the coast of the Yucatan Peninsula in Mexico. The giant underwater cavern is around 900 feet deep and spans an area of 147,000 square feet. Underwater images showing the second deepest blue hole in the world. The second deepest blue hole in the world has been discovered off the coast of the Yucatan Peninsula in Mexico. The giant underwater cavern, we read this already. That's just shy of the record set by the world's deepest known blue hole, the Dragon Hole in the South China Sea, which was discovered in 2016 and is thought to be more than 980 feet, 300 meters deep. Blue holes are large undersea vertical caves or sinkholes found in coastal regions. Many contain a high diversity of plant and marine life, including corals, sea turtles, and sharks. The one in Chetumal, named Tamya, which means deep water, in Mayan, has steep sides with slopes of almost 80 degrees, and the mouth of the cavern sits around 15 feet, 4.6 meters below sea level. Scientists from El Colegio de la Frontera Sur, ECOSUR, a public research center coordinated by Mexico's National Council of Science and Technology, first discovered it in 2021. A study of the find was published on February 23rd in the journal Frontiers of Marine Science. If you click on this link here, you will be able to go to the paper, which I really recommend you to do. That's a map of the hole. And here it's somehow from above on the left and the flanks of the hole on the right. Blue holes form when sea water meets limestone. Yes, we have to talk about Mountainwater, white rivers, cryptogeysers, and all these kind of things I've been writing about. Because I don't think that they are like sinkholes in the normal sense or whatsoever. Probably there has been water gushing out in the past at the moment of creation of these kind of structures. But anyway, let's just have a read through that. I won't interfere. I will put a link below to my paper. You can read about it. And there is so much other things which would be basically needed to say about this. But now let's go just through the article and you can make up your own mind. Limestone is very porous, so water easily permeates the rock, enabling chemicals in the water to react with the limestone, eating it away. Many of the world's blue holes likely formed during past ice ages, when the repeated flooding and draining of coastal areas eroded the rock and created voids. Yeah, we are back to the 12,000 year cycle when stuff went down. Electromagnetic discharge events and such. So I think this cave is also related to these and not so much to erosion. When the last ice age ended around 11,000 years ago and sea levels rose, the caverns filled with water and some were completely immersed. Huh, yeah. Because blue holes are so hard to reach, scientists haven't studied many of them, which could indicate that they probably don't know too much about it. They are largely poorly understood. Okay. Christopher G. Smith, a coastal geologist at the U.S. Geological Survey (USGS), has studied other submarine sinkholes but was not involved in the latest research, told Life Science in an email. Smith added that the unique seawater chemistry in blue holes suggests that they may interact with groundwater and possible aquifers. Yes, this is what I'm trying to tell you as well. Bodies of rock or sediment that hold groundwater. I just recently made a video about the thousands of volcanoes they found on the seafloor. How many volcanoes they would find on land if they just would know what to look for. Blue holes contain little oxygen, and sunlight only shines on the surface. Despite these conditions, the gigantic voids are teeming with life that has adapted to the low oxygen environment. Blue holes may offer a snapshot of what life was like thousands of years ago. Yeah, just look at the chicken. You will see a dinosaur. Without much oxygen or light, fossils can be well preserved, enabling scientists to identify the remains of extinct species, the researchers noted in the study. Blue holes may also tell us more about life on other planets. In 2012, researchers peering into blue holes in the Bahamas found bacteria deep in the caverns where no other life forms dwelled. Such findings could offer clues as to what life may exist in extreme conditions elsewhere in our solar system. Yeah, and many, many other places. You know, our solar system is a tiny speck. So now let's go quickly to the paper, which can be found here. This is maybe something to download, just in case if it would disappear from the net. Never know, download. Because there was something very interesting. Coastal karst formation may remain unexplored by the global marine scientific research community. Knowledge provided by fishermen coupled with scientific research on karst formations prompted us to explore the geomorphometric and physiochemical features of a submerged blowhole in the large tropical estuary of Chetumal Bay in the southeastern coast of Yucatan Peninsula, Mexico. Very long sentence. Here is basically a map, you can see it. Chetumal Bay, Mexico, Bacalar, Belize. Here is maybe easier to. Yucatan Peninsula. And that's a map from above, I guess, about the depth, minor axis, major axis. For example, here, morphometric features. That's the picture of the hole. Yeah. And they tell that the edge of the Chile is at a depth of less than 5 meters below sea level, which is the depth of Chetumal Bay in that location. So we have to assume it's mainly flat and there's a hole, and then it continues. We can talk about how it being so flat, we can talk about this another time, but geo-referenced raster images collected from side-scan sonar rear recordings and drone surveying identified a nearly circular shape for the mouth of the blue hole. A series of discontinuous terraces were detected at water depth less than 10 meters below sea level, near the eastern and northeastern walls of the blue holes, and before developing steep and almost vertical slopes. The southwestern wall of the blue hole was steepest, with a 10-to-1 slope ratio. Yes, time to wake up. In order to understand how circular craters can form, we might have to understand that what Birkeland Currents are, also known as field-aligned currents, discovered by Christian Birkeland many years ago. So this is basically, if that's Earth, and there's the Birkeland current coming in and it goes out and in, energy goes in both directions, which is the magnetic pole of Earth. Here we can see the auroras. So the Birkeland currents are every now and then visible. Like they were 2 days ago. I know it's very bad quality. Maybe you can see it. Here are greenish glowing. Yeah, it's rather bad quality. Maybe once when I get big, I get a camera which can capture stuff like that much better, because they were like nicely visible with the eye, but I didn't expect that I would catch too much of them. Birkeland current. And in order to get maybe an even better grip of the understanding of the circular shape of that hole, we can take a look at the Birkeland current simulator. That's a Birkeland current. It's circular in shape. It has coaxial movement. And I will put a link below. You can check this out by yourself. It's very interesting. You can play around. There's like different kinds of things you can do with that. You can zoom in and switch it around and watch from all directions. But it doesn't change the fact that it's almost round. So this could be a nice indicator for electricity playing a huge role in the creation of that hole. And now yet still another one until the video gets again too long. Morphological and biological insights. Biofilm sediments and irregular shaped rocky ledges on 2 to 3 meters were identified covering the internal walls of the in the water column between 15 and 20 meters below sea level. A layer formed by detrital particles was noted with a general diffuse light and decreased visibility. The detritus was not uniformly distributed inside the blue hole, and visibly across the sections at the same water depth differed. In addition to the diffusion caused by the detrital layer, light penetration was minimal and artificial light was used. Now, listen. I have been talking about the white rivers, about calcium and alkalinity, and potassium and stuff like that. Tufa ditches, where like very calcium-rich water comes to the surface of the earth, it emits CO2 and it depletes calcium. So the whole well is basically growing over time because it depletes this calcium. And I think that's something which has to do with volcanic activity, because we are talking about groundwater, geothermal activity and stuff like that. So they are all tied together. Now, there have been, or this other dude, which wasn't included in this study, already talked about groundwater. Settle it. No, Meton. The walls of the blue hole were covered by a fine-grained layer, presumably gypsum. You know, there is mineral water coming out there. Maybe not all the time, maybe it will different, maybe there's like, you know, they don't know too much about it yet. But if that's just basically a crypto geysir or crypto dome, basically a volcano underneath the sea, but yet another is maybe not seen as such. But I would just say because there is a fine-grained layer, presumably gypsum, coated by brown algal biofilms which easily disintegrated under aggregation or pressure. I think that's very interesting that we have gypsum there. So we have to assume that it might be still alive, so to say. And the fluctuations or the amount of water coming out of the underwater aquifer, it might fluctuate. There might be times where there is nothing almost coming out, and there might be times when there is like very much coming out. For example, let's go still quickly to my paper. Yeah. Mountain water, a new approach to mountain forming volcanism glaciers and the role of water in an electric environment. This is the paper I meant. It just got released some weeks ago, and I talk about water quite much because textbooks and geoscientists may be wrong about how the Alps formed. Yes, but we are talking about many other things as well in this paper. Sun cycles, dragons, pilot dwellings. But now let's go just to the end and beyond. Why I say this? For example, let's just have a quick look at this picture. That's on the left, that's the sun, where we have a solar flare going on. And there is this arc which goes through that. So it touches the ground here and here. In comparison, this would be this thing, and this would be that. The Eiffel volcano and Campifligre. And in the middle, here, where we have those loops going, this would be the Alps region. But anyway, let's go to the end and beyond. There are pictures like this in the article. Maybe one day I'll figure out how to make straight lines with a cell phone on a picture. Conclusion, and now we have the reference list. And after the reference list, we still have this addition, which is obviously called addendum. Yeah, the process of learning should be driven by curiosity and based on the honesty towards oneself. Does anything of this make sense? This is a question which should be asked every now and then, and it has to be answered honestly. If it doesn't make sense, the idea must be thought over at least. My research about this topic is far from over. Yeah, I'm making once again a video about mountain waters. It's not over. And new evidence appears daily. Yes, the second largest blue hole. This substitute shows three things which I thought are so important pieces of evidence worth adding, but weren't included in the paper. Yeah, there would have been dozens of others. But we want to watch at Puas Vulcano, Costa Rica. Yeah, we have the Nika caves. Giant crystal caves are existing. In my paper, I talk about crypto geysers. It is a term I invented in order to describe water sources which could produce sudden and unexpected, rather large eruptions, mostly by water. Yeah, water is so abundant. So it shouldn't be outrageous to think that, yeah, there might be many volcanoes. Since we have volcanoes, they are erupting like all kinds of different kinds of lava. Like almost all people associate volcanic eruptions with lava, red flowing lava. That's the point where I think why the tiger is such an important animal, because it might represent lava flows. I made videos about that. But anyway, there might be ash and stuff coming out, and steam, and many volcanoes. They have a lake at their caldera, Mount St. Helens in the USA, there is growing the world's fastest growing glacier. Aha. It's a crypto dome. But anyway, we have to keep in mind that the main trend in geothermal volcanic and seismic activity has been decreasing for a long time, maybe several hundreds of years. As a possible indicator of decreasing geothermal activity, we could take the abandoned castles in Central Europe. The reason for them having been abandoned might not be only political, but also the well which provided it. Man. Yeah, this was a bad mistake. I have to move to some other place because they won't stop now. Oh, anyway. Yeah. The reason for them having been abandoned might not be only political, but also the well, which provided the inhabitants with water, dried up. Another example could be some findings by archaeologists which found ruins of Roman built baths, but no water. Where is it? Maybe I just would have to continue reading. Furthermore, we have to understand that back in the days of the Romans, for example, the geothermal activity in Europe might have been much bigger than it is nowadays, meaning that many places are by far not as active, hot, or rich in minerals as they were several hundred or even thousands of years ago. Bruce Leyburn brought the Povas volcano to my attention because its eruption style is often described as giant geyser-like eruption. It can produce water columns up to 4 kilometers high. A giant geyser indeed. Povas volcano is a very interesting volcano consisting of different parts of activity. It contains also one of the world's most poisonous lakes with a pH of almost 0. The volcano has 3 different lakes and each has its very own personality. Yeah. And we have now gypsum depletion in the world's second deepest blue holes yet ever discovered. Mountainwater, I think. Underground aquifers, fluctuations of the water amount pouring out there, not only in the amount, but also maybe in temperature and composition. Very interesting. Conclusion. Giant geysers are existing and are not something needed to be imagined. Yeah. How many of these are all over the world? I don't know. There is a lot of work still to be done. Thanks. Bye.